This segment will review the innervation patterns of the lower limb and how they relate back to the formation of the nerves in the plexus.
To understand some of the patterns of muscle innervation in the lower limb, we need to revisit the idea of limb rotation during embryological development. We can see on this figure three anterior views of a developing embryo at various stages. The first one here shows relatively early development. We can see the stripes of the dermatome patterns on this embryo, but we can also see the palmar surface of the hand and the plantar surface of the foot, both facing anteriorly. Over time, the upper limb rotates slightly laterally and the lower limb rotates significantly medially, such that we finish up not only with a change in the dermatome patterns on the lower limb that we can see over here, but more importantly for the muscles, it means that the embryological dorsal muscles actually move on to the anterior surface of the limb. So that rotation has resulted in a relocation of the major muscle groups. So this principle related to the opposite directions of rotation for upper and lower limbs means that we actually see the relocation of the major muscle groups in the lower limb, whereby the dorsal muscles that are typically extensors will have moved to the anterior surface and the ventral muscles that are typically flexors will have moved to the posterior surface. If we look at some principles related to the nerves that innervate these different groups of muscles, you've met these principles previously, but effectively the first one relates to the embryological dorsal muscles that typically produced extension, but also abduction or external rotation in the limbs, are usually innervated by nerves, not surprisingly, derived from the posterior divisions of the anterior primary rami. Whereas the muscles that were embryologically ventral, that typically produced flexion or adduction and internal rotation in the limbs, are usually innervated by nerves derived from the anterior divisions of the anterior primary rami. We've just in the previous segment looked at the origin of the major nerves coming into the lower limb from the plexi and looked at which nerves derived from posterior divisions and which ones derived from anterior divisions. We've also looked at the exits that these nerves take from the pelvis. So if we look at this table, what we've identified in the two left-hand columns are the major nerves that innervate muscles in the lower limb, and whether those nerves are derived from anterior or posterior divisions in the plexus. We've also indicated the exit by which each of these nerves leaves the pelvis, and that will give us some clue to the location of the innervated muscles. Now, what we've completed on this table is probably the most difficult one, in that it leaves via a posterior exit, but the common peroneal nerve eventually makes its way to the anterior aspect of the leg, and the muscles that are located there have dorsiflexion of the ankle as their primary action. And dorsiflexion, as you'll talk about during the semester, is actually true extension. And that fits with the idea that this nerve derived from posterior divisions, as we identified on those previous principles. What I want you to do is to complete the rest of this table by thinking about firstly the location of the muscles that will be innervated, and these are much more straightforward than the one that I've already completed, and therefore the likely actions of those muscles that should link back to the divisions that nerve derived from in the plexus. I'll ask you to pause the video now while you complete that exercise. Hopefully you've been able to complete the rest of this table, but let's run through your answers just to check. If we look at the lumbar plexus first, the femoral nerve, because it comes out deep to the inguinal ligament, will actually finish up running into the anterior aspect of the thigh, and the major group of muscles in the anterior aspect of the thigh are the quadriceps muscles, and their primary action is extension of the knee, and extension fits with posterior divisions. The obturator nerve, on the other hand, by going through the obturator canal, actually finishes up in the medial aspect of the thigh, and the muscles in the medial aspect of the thigh primarily act on the hip joint. Because they're located medially, they will adduct the hip joint, and adduction fits with anterior divisions. If we look at the nerves of the sacral plexus, all of them exited via the greater sciatic foramen, so we expected them to lie in posterior parts of the limb. In fact, the two gluteal nerves, quite clearly by their name, remain in the gluteal region and innervate muscles there, and those muscles are therefore going to be posterior or lateral to the hip, and therefore they will extend or abduct the hip, and both of those actions are consistent with a derivation of a nerve from posterior divisions. The tibial nerve, on the other hand, derive from anterior divisions, and anterior divisions are consistent with actions of flexion. The tibial nerve passes through the gluteal region and down into the posterior thigh and leg, and the muscles in those compartments are primarily responsible for flexion of the knee and also plantar flexion or true flexion of the ankle joint. So we can see that the principles relating to derivation of nerves in a plexus and the actions of muscles that they innervate seem to work fairly well. However, some of you might be saying that the anterior thigh muscles, the quadriceps, one of those also crosses the hip joint, and because it's anterior to the hip joint, it would be a hip flexor, and the idea of flexion doesn't fit with a nerve derived from posterior divisions. This is a good observation, and it's important to note that principles are generalizations and there are occasionally going to be exceptions. Particularly because the lower limb is rotated, these exceptions are likely to occur around the hip joint, whereas the principles apply fairly clearly from the knee joint downwards. Another concept that many students find difficult is the contrast between dermatomes and cutaneous nerve distribution. We can see those two distributions on these diagrams. On the left here is the dermatome distribution, where sequential segments innervate adjacent areas of skin, and on the right is the innervation pattern of the cutaneous branches of peripheral nerves. So for example, the femoral nerve innervates the area of skin here outlined in orange, and it also innervates the area of skin outlined in purple through its saphenous branch. We know that the femoral nerve derived from L2, 3 and 4 segments in the plexus, and therefore it's not surprising that if we compare these two diagrams, the femoral nerve is innervating parts of the L2, the L3 and the L4 dermatome. In contrast, if we consider the L2 dermatome, we can see that not all of it is innervated by the femoral nerve. In fact, over here medially, we've got an area that's innervated by the obturator nerve, and over here laterally, an area that's innervated by the lateral cutaneous nerve of the thigh. Again, this is consistent with the origin of these nerves in the plexus, that is, the obturator, the femoral, and the lateral cutaneous nerve of the thigh all received fibres from the L2 spinal segment, and therefore logically all contribute to the L2 dermatome. The important thing to remember here is that it's exactly the same sensory nerve fibres that are involved in both of these concepts. If we were to describe this in words, we could say that the anatomical basis for this contrast is that we have a distribution of fibres from one segment into several peripheral nerves. In other words, several peripheral nerves will contribute to one dermatome. Or we can say that we've got distribution of fibres from several segments into one peripheral nerve, so therefore one peripheral nerve will contribute to more than one dermatome. In fact, this same concept is also relevant to the contrast of myotomes and muscular branches of peripheral nerves. I'm not going to give you the answer to this one, but you could try this at home and post your answer on the LMS. What I'd suggest you try and do is compare the L4 myotome to the muscular distribution of the femoral nerve.